Now we can do the last part, and it's gonna be a really quick part. Fast calculation, and this is the best method for calculating polynomials. Why is Horner method the best? Because let's look at what happens if I want to calculate this polynomial at the value for x equal 2. Let's look at the normal method. Just put the 2 inside, here, 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 and here, and do some operations. So you would do here 4 multiplication, here 3, like because 3 for the multiplication of x plus 1 because multiply 10 with that. So here we have 4, 4, 3, 1, and 1, 2, 3, 4 additions. So we have 16 operations. Let's look at the Horner method. This is the same polynomial. I just wrote it a bit differently. I just wrote it like that. So here is x, and then now let's count. I have 1, 2, 3, 4 additions and 1, 2, 3, 4 multiplications. So 8 operations. It's by a lot beating these operations. You don't want to write that. So how do we actually write it down in the exam? Let's say I want to calculate p of 2. We do the same thing as here, but written in a way that we do make less mistakes. In this direction, it's a plus, and this direction is gonna be a times. You can compare between what we are doing here and what we are doing here, and you see it's the same. So let's go. Just starting from this inside parentheses, then there, then there, then there, then there. We have the 1, we put it down. Then we multiply by this, which is 2, so it's gonna be 2. We had the two numbers together, minus 8. So now we multiply, minus 16. Now we add, 19. Now we multiply, it's gonna become the 38. Then minus 12, then minus 24. And, oh, nice, 0. Which means that p of 2 is equal to 0. So I can factorize by this root, so x minus 2 times, here we have x4, x to the power of 3, x to the power of 2, x, and x to the power of 0. Here you have to the power of 4, so here you have 1 power less. And 1, x per 0, and this is just the answer. So we can write a square minus x like that. Now, of course, you can repeat, you can guess what are the other roots, but let's go on the second topic, the factorization. This is where we are left, and how can we find the other roots? We look at the last here, and the multiplication of the roots will go to the last element. So we try the divisors of this, so it will be these. The spoiler is that the roots from this polynomial is here, so you don't have to do it. So we can factorize this polynomial as x minus a root, so it's going to be like that. Careful, if let's say that the root will be minus 1, for example, then here it will be a plus. Let's practice. Factorize this polynomial, and then I want you to give me a polynomial with the roots minus 5 and 7. Pause the video. Let's go. This is what we call the standard form, and we want the factorized form. So first we look at the end, and it's a product of the roots, so we are trying the divisors of plus 9, which are 1, 3, and 9. Of course, minus could also be a possibility. And you try, and you end up with, for example, trying with x equal 3. It's 0, so the polynomial at the 3 is equal to 0, which means that, but you don't need to actually just write it down like that, but you can. You can directly go with these values and write them here. And here I look at that. I'm just gonna try this directly, and oh, nice, it works. I've found another root. If it doesn't work, if it's something else than 0, not problem, just try something else. You're gonna find it. Usually in exam questions, it's not hard to find. So if you have a problem finding it, maybe there's an error somewhere. Maybe in your error schema, you multiply or added something, and minus become plus, whatever. Now I can write it. It's like that, because here it's x, because it's like that. I directly have the factorized form. So this is the factorized form. I had the standard form. Now I have the factorized form with the roots. Nice. I'm done for this first part. Now I wanted a polynomial with the root minus 5 and 7. It's like that, because I don't have no more indications about whether things should be complex or reals. If you don't know what a complex number is, don't worry. In a few videos, it's gonna be the topic. This was a big video, so let's recap. So we had relations, and we saw that there were many properties. We sorted them into threes for equivalent relations, order relation, and total order relation. We saw how we can understand them more easily with those kind of scheme. And we saw equivalent classes. When a relation is an equivalent relation, then it builds equivalent classes on the set. Then we saw functions, and we saw the three most important properties of functions. We saw the notation that is tricky, not difficult, but tricky, because you have to be careful. This is the inverse function, this is not the inverse function. You saw polynomials, and we saw that it's not difficult, it's about if you use a Horner, and we saw how to find the roots. And that's it for today. Nice, we made it! See you tomorrow for the next video about groups and fields. If you wonder why there is a duck here, it's gonna make sense in the next video.